Hello, today we're going to be talking about functions and function notations. So the first goal is I can determine whether a relation is a function. So a relation is a set of ordered pairs, for example, 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. Remember that ordered pairs is your x, y. A function f is a relation that assigns a single value in the range to each value in the domain. So now we need to know what the range is and the domain is. It just means that x values cannot repeat. So to be a function. So let's just look at a table of values. You have your inputs and you have your outputs. And your inputs are called your domain. These are your x values, and they're also known as independent variables. Your outputs is the range, it's the y values, and it's the dependent variable. So this right here is an example of a function because the x's are not repeating. You have 1, 2, 3, 4, 5. Those are all distinct different numbers, and they're going out to a number, y. Okay, so let me give you a graphical example of functions. So graphically, any line is a function. So if we have just this line right here, that's a function. You can have a mapping. So this is your input, and in your input you have Anna, Mary, and Lola. This is your output. You have Mike and Jake. And so Anna can go out with Jake, Mary can go out with Mike, and Lola can go out with Jake. So all of these have an output. Now it's okay if the y's repeat. So see how Anna and Lola are both going out with Jake? That's okay. However, Anna cannot go out with Mike and Jake. That would not be a function. Okay. So let's take a look at the coffee shop menu. So you have items here, plain donut, jelly, and chocolate donut. And here's a price, $1.49, $1.99, and $1.99. And the question is the price a function of the item? So first of all, the price is your output, and your item is the input. So yes, this is a function. Why? Because each item has one output. Now look at part B. Is the item a function of the price? So the item is your output and the price is your input. So really you have $1.49, $1.99, and $1.99 for your inputs. Okay, so these are your inputs. And then your outputs are your donuts or your items. So you have a plain, you have a jelly, and you have a chocolate. I'm just going to put choco for chocolate. So $1.49 goes to the plain. But then $1.99 goes to the jelly and the chocolate. Oh, you don't have to write it twice. So this $1.99 is going out with two different donuts. So this is not a function. Okay. Example of non-functions. So Joanna goes out with Peter. Alyssa goes out with Tom. Mia goes out with Mike. Alyssa goes out with Bryce. Alyssa's going out with two different people, so that's not a function. And Joanna's going on with John. So, no, not a function. Okay, so what if you have a mapping? This is your input, output. So then even, 2, 4. It's going out with two different numbers. Odd, 3 and 5. Going out with different numbers, so not a function. Okay, graphically, what's not a function? Okay, so a circle, is not a function. And then if you have a set of ordered pairs, you have your x and your y, x, y, x, y, x, y. So look at your x's. They repeat right here. One is going out with -1, and 1 is going out with +1. So not a function. Not a function here. Okay. So now we're going to find the value of a function. First of all, let's talk about function notation. We name the function f, g, or h, or even other names as well. So if we have f of a, that does not mean f times a, it means f of a. F is a function of a. This would be g of x. G is a function of x, and h of x. Remember that when you have f of x, your x is your input, okay, which is your domain, your independent variable, and your output is your y. Okay, so this is your range. Okay, so here you say f is a function of x. So we're going to look at example 3 from the online book. It says a function n is equal f of y gives the number of police officers n in a town in year y. What does f of 2005 equal to 300 represent? So 2005, that's your input. It's the number or the year, not the number, but the year. And 300 is your output, and that's the number of police officers. So this town in 2005 has 300 police officers. Okay, so now we evaluate. We're going to do example 6 from the book, online book. We're given f of x is equal to x squared plus 3x minus 4. Evaluate at 2 at a plus h, and then f of a plus h minus f of a over h. This is called the difference quotient formula. We'll talk about it later. Okay, so f of a just means you're going to plug this 2 into all the x's, okay? So then that's 2 squared is 4 plus 3 times 2 is 6 minus 4. The 4's cancel, so it's 6. Okay, a, you're just plugging the a into the x's, so now it's a squared plus 3a minus 4. And then you have f of a plus h, you're plugging the whole a plus h wherever you see an x. So it's going to be a plus h squared plus 3 times a plus h minus 4. So this is where kids get mixed up because they just think it's a squared, h squared. No, this means a plus h times a plus h, and you have to use FOIL. So you're going to multiply those two, that's AH. That's going to be AH. Remember alphabetical order? A goes first and then the H. And then H times H is A squared. Then we're going to distribute that. That's going to be 3A plus 3H and then minus 4. Now, the only two things we can combine are these two. So that's A squared plus 2AH plus H squared plus 3A plus 3H minus 4. So this right here is f of a plus h. That's what that equals. Okay, so now we're going to replace all of this and we're going to plug it into the f of a plus h. So then we're going to have a squared plus 2ah plus h squared plus 3a plus 3h minus 4. Then you have a subtraction right here, and then f of a we just calculated is that, but we have to put it in parentheses, all over h. And so now we got to distribute the minus So that's really minus a squared minus 3a plus 4. And we're going to combine like terms. So a squared cancels with that. The 3a cancels with the minus 3a, and the negative 4 cancels with that. So now you're left with 2ah plus h squared plus 3h all over h. Now notice that all of these have an h in common. That means I can factor out an h. So that's 2a. So common backward distributed property, plus h plus 3. So if I were to multiply that, I get that. H times h is h squared, and then h times 3 is 3h all over h. So those cancel. So then your final answer is going to be 2a plus h plus 3. And that's your final answer there. Okay, example 9. Express the relationship 2n plus 6p equals 12 as a function of p is equal f of n. So that means you have to solve for a p. So you have 2n plus 6p equals 12. And so I'm going to subtract the 2n, subtract the 2n on both sides. You're going to bring down the 6p. That's negative 2n plus 12. Divide by 6 everywhere. So then p is equal to negative 1/3 n plus 2. And then what we're going to do is we're going to replace the p with f of n. And so this is your function of n. That's your answer right there. Okay. Example 10. Does x squared plus y squared equal 1 represent a function with x as the input and y as the output? So that means y is the output. That means to solve for y. So we have x squared plus y squared equals 1. So that means I'm going to subtract the x squared. So that's going to be y squared equals 1 minus x squared. And then to get rid of the square root, I have to, or the square, you have to take the square root, sorry. And it's plus or minus the square root of 1 minus x squared. So then that cancels with that. And you have y is equal to plus or minus. So that means you have two answers. One is a positive and y is equal to a negative. So because y is going out with two different functions, one with the positive function and one with the, this is not a function. Okay. Example 11 from the book. Evaluate, given a tabular function, evaluate g of 3 and solve g of n is equal to 6. So they give you the table here. N is 1, 2, 3, 4, 5. And g of n, your output. So this is input, output. So that's saying g of 3 means you go to 3 and your output is 7. So this equals 7. That's your output. That's your input. Okay. And then this one says solve g of n is equal to 6. So that's your output. Then n is equal to, so if your output is 6, that's your output, then your n is 4. So that's your answer right here. Okay. Now let's use a graph to evaluate f of 2. So that's your input. What's the output? Well, you're going to plug, so on the x is your input, so here's 2. And then 1 is your input. Okay? So, I mean, 1 is your output, sorry. Sorry. Okay, and then this one's your output. So here's 4. Your output is 4. So right here, this is 4. So you have 2 inputs at 3 and at -1. So x is equal to -1 and +3. And then this one says solve f of x equals 1. So that's your output. Okay, so it's right here. So you have it right here and right here. So x equals 0 and 2. So if you input a 0, then if your x is 0, then your output is 1. If your x is 2, then your output is 1 as well. Okay, we're almost done with this section. 1-to-1. What is a 1-to-1 function? A 1-to-1 function is exactly when the input corresponds exactly to one output. Okay, so for example, if you have 1, 2, 3, 4, and they go 6, 8, so all of these are different, all of these are different. Right here. So this is 1-to-1. This one over here is not 1-to. It's a function, but it's not 1-to-1. So because negative, and this is y is equal to x squared. So if I plug in a -2, I get 4. But then if I plug in a +2, I get 4 as well. If I plug in 1, I get 1. -1, I get +1. So these repeat. So then that's not 1-to-1. Okay, the vertical line test says that if I get a spaghetti, let me come get a spaghetti. Where's my spaghetti? Oh my goodness. Here it is. I forgot my spaghetti. I knew that. Okay, so vertical means you're like this. So see how when you have a spaghetti, this circle touches the spaghetti twice. So that means this is not a function. The line is a function because wherever I put my spaghetti, which is a vertical line, it only crosses the spaghetti once. If I put it right there, it only touches it once right there. So this is a function. Again, right here, it only crosses it at one point. Wherever I put my spaghetti, it only touches that V shape, only touches the spaghetti once. Right here, once. So this is a function. So vertical. So right here, the spaghetti gets touched 1, 2. So not a function. So you can use the vertical line test very easily to do that. And then the very last thing that you're going to learn about is the basic parent functions. You guys should already know about this. The constant, y equals c, is just a horizontal line. Horizontal line. So c is just any number. So if I go right here, go to y equals, and I press 3, and you graph it, notice that it's just a horizontal line on 3. Okay, y equals x. So that's just your basic function. If I just put x, you're going to graph it. It just goes like that, okay? So these are your basic functions. You have your absolute value function. It's a V shape. Quadratic is a U shape. The cubic is kind of like a snake. The reciprocal, y equals 1 over x. And then we have y equals 1 over x squared, so it goes like that. And then the square root. And y is equal to the cube root of x. So all of these are functions that we have already studied in Algebra 2. You guys have seen all of these parent functions. So go ahead and work on your assignment for today. Good luck.